Hi, I'm Rich with Inside HPC. We're here at Salt Lake City in SC12 at the Scalable Informatics booth. I'm here with Joe Landman, CEO of Scalable Informatics. Joel, let's start at the beginning. Who is Scalable Informatics and who do you help?
Well, good morning, Rich. Good morning, Inside HPC viewers. In a very short, simple face, we make very fast storage and computing systems. The customers that require extreme performance storage, extreme performance computing, leverage our platforms for modeling and for time series analysis and for massive database type of work. We typically work with financial services industry or media streaming or life sciences or engineering and supercomputing type of customers.
Okay, so it's all about moving data quickly and storing it in high capacity. So what's new and exciting this week at Scalable Informatics?
Well, we're actually showing off two new products. We have an updated version of our JackRabbit storage and computing unit. This unit has been one of our mainstays for the past several years, and we've updated it with a 60 drive bay chassis along with a 16 processor core and much higher memory computer in the back end. We've added a capability for up to 11 PCIe cards and substantial InfiniBand 10 and 40 gigabit Ethernet, as well as other I/O type of expansion capability.
Okay, so what kind of performance, real world application performance are you seeing on this box?
Well, our initial tests, because we actually literally built the first one last week, our initial tests are showing us approximately 80% efficiency as compared to what we'd like to see, about 90%. And we're seeing on the order of about 7 gigabytes a second sustained reading and writing to the disks. And this is with applications such as KDB Plus, which is a financial time series database, and it's an integrated query language. Think of a NoSQL with an embedded computing a portion. There is another element of this, which is actually something we just released this morning in terms of a press release, and that is we're adding in not just 16 processor cores of our friends over at Intel, we're also adding in the 192 processor core Calxeda Energy Core processors, and that is a wonderful, wonderful situation for anyone involved in very large data, very big data, Hadoop, and other types of operations.
So what is the Calxeda, what does that bring to the table then? Is it all about energy efficiency or density or what?
It's actually a combination of several things. It brings a great energy efficiency. Obviously, the per processor core power usage is much lower than the Intel units, but it also brings a massive scale, 192 processors in a very small container, and that will only get better over time as the technologies improve for the manufacture of these ARM chips.
Okay, so what are we looking at here, Joe? What is this about?
So this is actually a demo of our siFlash unit. Our siFlash unit is operating in the chassis behind you, but we're running, as it turns out, this is a random read. We're cycling between every 60 seconds between a random read and a streaming read from this storage. We're doing a 32K type random read across 1 terabyte of data spread out on our flash unit. And while we're doing it, we're sustaining a little more than 1/3 of a million IOPs and roughly about 10, 11 gigabytes a second. When it switches over to the streaming read, the IOP portion is a little bit less important. It'll drop down a little bit, and the streaming read portion will vary between about 10 and about 14 gigabytes a second sustained. So this is a relatively newer version of the system that we had brought out about 6 months ago, and it's much more optimized than it had been when we brought out the initial unit.
Joel, I'm a big reader of your blog. It's all about it's about scalability, right?
Yes.
Scalability.org. Is there a buyer beware kind of message about performance and what you see in benchmarks and stuff? That seems to be the theme running through there.
Yes, we run into this all of the time. One of our one of our biggest concerns about performance benchmarking is very often people will grab packages and look at the package and say, hey, I've got an SSD which has 50,000 IOPS and half a gigabyte per second performance. And the reality, when you go insert that into a unit and use it in a day-to-day environment, you see it's anywhere between 2 to 10,000 IOPS and maybe about 250, 300 megabytes a second at best. Those sorts of scenarios We see that all of the time. We see people reporting, you know, 1 million, 2 million, 3 million IOPS. We don't see people actually using them in day-to-day type operations. The queries and whatnot else running behind you actually are models, if you will, of the queries that our customers make use of. So we analyzed the I/O patterns, we re-represented those in FIO or other types of benchmarks, and then put those on our system just to be able to test our system when we couldn't get their actual code. And what we see generally is when you make use of a system which has all these astounding benchmark claims on the marketing site, your actual performance is usually a fifth to a tenth of what they claim, versus when you actually build it and test it and optimize it based on that. So we're very strong proponents of actual testing as compared to believing benchmark numbers.